Hey, how you doing? I'm Elton, and this is the third part of the Docker MTA series, Modernizing .NET Apps for IT Pros. In part 2, I showed you how to migrate a .NET 3.5 app running on a Windows Server 2003 VM to Docker using image to Docker. You can use the exact same approach for ASP.NET apps using .NET 2 through to .NET 4, where the source is Windows Server 2003, 2008, 2012, or 2016. One of the big operational benefits in moving to Docker is the ease of deployment. In this video, I'm going to show you the upgrade workflow, which is fast, automated, and safe, and it's the same for application updates as it is for Windows updates. I'll show you how to tag images, so you can have different versions of your app, how to store your images in a private registry, and how to update your applications by running a new container from a new image. I finished the last video by running my .NET 3.5 app in a Docker container on Windows 10. The image for that container is stored on my laptop right now, so before I can run the app on other machines, I need to share the image. You share Docker images on a registry, and there are lots of registry servers to choose from. You can use Docker Hub for open source apps, Docker Cloud for private apps, and Docker Store for commercial apps. I'm using Docker Trusted Registry, which is a private registry you can run in your own data center or in a virtual private cloud. Docker Trusted Registry, DTR for short, has a rich authorization model. I've created an organization for all the images related to the newsletter app, and in that org I have several teams. You can set permissions for accessing images on the teams, so here DBAs have read and write access to the database image, but only read access to the web application image. That means users in the DBA team can push new versions of the database image to the registry, and they can pull the application image to run it for testing, but they can't push new versions of the app image. My account is in the admin group, so I can push and pull both the app and database images. Docker image list tells me the images that I have locally. To push the image to the registry, I need to give it a tag which includes the registry domain. Docker image tag adds a new name to an existing image. My original image reference has the repository name, the image name, and a version number. I'm adding my registry domain, dtr.6i.com, to the start of the image reference. Now I need to authenticate with Docker login using my credentials for DTR. And to upload the image, I run Docker image push using the new tag. When all the layers have uploaded, I can see the image listed in DTR, and now that's available to download and run in any other environment. I have a VM running in Azure using Microsoft's Windows Server 2016 with containers machine image, which comes with Docker installed. This VM doesn't have IIS or .NET 3.5, but I can still use it to run my traditional app because all those dependencies are now bundled in the Docker image. I'll log into the same private registry and pull the application image. This is going to be a test environment, so I'll also pull the database image so I can run SQL Server in a container too. I won't start the app by running individual containers. Instead, I've got a Docker Compose file which I'll use to run the whole application. Docker Compose is a tool for defining multi-container applications, configuring them with the same options that you use when you run individual containers. I have the database definition here and the web app here. To start the whole app, I run Docker Compose up-d, which starts both containers in the background. And that's it. My app is deployed to the test environment now, and back on my laptop, I can browse to the VM in the cloud and use the application. This app is using exactly the same Docker images, so the behavior is the same as when I run it locally. I can add a new set of user details, and back in the VM, check the container logs and see the output. This is how the deployment process works in Docker. You build the image, push it to a registry, and then use the same image to run your app in different environments. When you deploy your app to production, you're running a container from the same image that's been tested and approved in all the QA environments. The image I'm using as the base for my application is a public image with ASP.NET 3.5 already configured. It's tagged to a specific release of Windows, and when Microsoft provide Windows patches, they also push updated versions of their Docker images. The way to apply Windows updates to an app running in a container is to build a new image from the latest Windows base image, and then replace your container with a new container from the new image. My app is currently based on revision 1198, and if I check on Docker Store, there is a later version available. 1480 will have hotfixes and security patches, so to update Windows, I just change the from line in the Docker file to use the 1480 tag and then build the image. I'll use the same image name so I can push this image up to my DTR repository, but I'll use a different version number in the tag. The very first instruction in the Docker file has changed now, so that breaks the cache for the rest of the layers, and Docker will execute all the instructions in the build. When it completes, I push the image in the same way, and here's how it looks in DTR, the same repository but a new version of the application. To update my test environment, all I need to do is change the image version in the Docker Compose file, specifying v3 instead of v2. Now I can repeat the Docker Compose up command. Docker Compose checks the desired state in the Compose file against the containers which are currently running. It sees that the database definition is unchanged, so it leaves that container running, but the web app definition has changed, so it stops the current container and starts a new one. This is the update procedure when you have a single server running apps in Docker. It's fast, simple and safe, and it's easy to automate in a continuous deployment pipeline, so there are no manual steps to deploy application updates or to roll out Windows updates to all your apps. Using a single server does mean some downtime while the app is updated. In the few seconds when the old container is stopped and the new one is being started, there's nothing running to process requests. But Docker supports zero downtime updates in high availability environments, where you have multiple servers running in a Docker cluster, and I'll show you that in the next video. At the start of this video, I had my app running in a Docker container on my laptop. Now I have the app running on a server in the cloud using the exact same Docker image that I've tested locally. The image is stored in a private registry where I have fine-grained control over who can access it. And Docker Trusted Registry has many more features than I've had time to cover, like automated scanning for security issues in your images, webhooks for triggering your own workflows, and policies for automatically promoting images between repositories. Moving my traditional app to Docker has made it easy to then move it to the cloud, using a simple system test environment that just took a few minutes to create. In the next video, I'll look at running that app in a more advanced staging environment, with multiple Docker servers running in a cluster. I'll show you how Docker Swarm gives you zero downtime updates, and how you can easily scale your app up and down using containers. That's coming in part 4 of Modernizing .NET Apps for IT Pros.